We are on, in your books, page 50? 50? 50? Really? Wow, we're rocking. All right, so you all should be looking at this page that says Math 10 Trigonometry. Yeah? Yeah. Okay. Now, do you, because I know that one of the books has a misprint, do you all have BF, AF, CG, AG, and DH, AH? Yes, we are on a roll. Okay. Now, we are going to do a couple of weird things, right? Well, not weird, stuff that you already know, but we're going to do a few things for this. One, the first thing I would like you to do is connect A and F with the line. You need not get out a ruler, and connect B and F. All right? Now, the next thing I need you to do is, you already know from the 9th grade that you name sides of shapes by going from vertex to vertex. AF, BF, yes? But in the 10th grade, we added a wrinkle to that, and we said that is not how we name sides anymore. We like to name sides with a lowercase letter. The lowercase letter that we name the side with is the vertex that is across the shape. So this would be what side? Little a. And this would be what side? Little b. Cool and the gang? Excellent. They were a band from the 80s, Kool and the Gang, late 70s and the 80s. And in one of the greatest movies ever made, Pulp Fiction, Samuel L. Jackson's character, one of the greatest characters ever put on screen, said, Kool and the Gang, when he wanted to just say cool. And since then, people of a certain vintage, anybody who was around your people's age or older in 1994, hello, grade 8s! If you are very lucky, you will spend 4 months in here with me. Where was I? 1994. Right. If you are anybody who was older than about your age in 1994 knows that line. But as you get older, you still watch old movies that are very good, as you have all seen Wizard of Oz, for example. You watch old movies, but you lose the references. And when Samuel L. Jackson says Kool and the Gang, you do not know what that means, but now you do. If you ever become friends with me and you send me a text that requires me to respond with the word cool, I always send a picture of Kool and the Gang back to the person. And that is how I tell if that person is worth my time or not. Because if they send me back question mark, I never text them again. Sometimes, if I'm feeling especially frisky, I send a picture of Coolio, the rapper. Because that's another thing old people say, Coolio. So sometimes I send that. And sometimes when somebody says something funny, I do not send LOL back. I send a picture of Fozzie Bear, the Muppet. Waka, waka, waka. Which I also use as a barometer for whether or not that person is worth my time. All right. So, this notation right here, BF to AF, we are going to rewrite that in grade 10 terminology. BF is little a, AF is little b. Right? Now, what does that piece of punctuation mean in math class, not English class? Do not tell me that is a colon. What does it mean in math class? A ratio. Well done. So we are comparing side A to side B. How else do we write ratios in math class? There are 3 ways to write them. This is one. Karina. As a fraction. So we could also write this as, and I'm going to use a different color to do so, A over B. Is there another way to write a ratio? As a percentage, which is again a fraction, right? And how do we normally write percentages? In math class, if we're going to do work with them? Pardon? As a decimal. The other thing we would do is write this as the decimal of A divided by B. Is everybody cool with that? Okay, so now write that ratio. How long is side A? 3. How long is side B? 4. How would we write that as a fraction? 0.75. Is everybody cool? All right. Now, the next one I want you to do is C to G. So I'm going to go ahead and come over here, and I'm going to do C to G, right there. And I'm going to do A to G. Now, do the same thing. What is the distance from C to G? Eight over. What is the distance from A to G? Is it 8? 12. This is where the misprint is. C is supposed to be one higher. I knew there was one on here. C is up here. So it is 9 and 12. What do you notice about 9 and 12?
It can be reduced.
It can reduce to what? 3 over 4, which is what decimal? 0.75. Everybody cool? All right. Now do the last one. A to H and H to D. How long is that? Right. That one is correct. 15 over 20, which is 3 over 4, which is 0.75. Now, stop for a moment. That's okay, dude. Everyone is okay with this, yes? Now, take a ruler, if you have one, or just sketch. You needn't worry about it too much. But draw the hypotenuse from A to D. I should shorten that up. Is everybody cool with that? Now, please notice that the 3 triangles we have just made all share a couple of characteristics. One of the things is shared, not just the characteristic, the actual item is shared in all 3 triangles. What is the thing that is shared between all 3 triangles? Which angle, Bhavneet? Angles are named by the vertex. So what angle is shared? What vertex is in all 3 triangles? A. This vertex right here, which I'm coloring green, is in all 3 triangles, isn't it? Yeah? And when I compare the sides of those triangles, all 3 of them, I end up with the same value, don't I? Because the angle is the same. Does it matter how long I make either of those sides? No, because the length of the side does not affect the value of an angle. Does everybody understand that? That is why trigonometry works. If you draw this angle and you make a triangle with a 90 degree, you will always have this variable, this value. Does everybody understand what I'm saying? What if I change this A line, I put another line right in the middle here, and I put it up to there? Will that comparison be 0.75? Why? Because the angle is different. Understand? By the same token, if I draw this red line along this line here to the mall, and at the mall I turn left and walk out to MRC Arena out there, making a 90-degree angle in the mall, what will happen if I compare that side to this side? What value will I get if I do that division? If I continue this line on out to the mall and this line on out to MRC, what will my comparison between the two be? The same. Okay? If I draw this line to a star in the galaxy, and I draw this line to another star in the galaxy, will that change this angle? No. Will it change that comparison? No. And that, ladies and gentlemen, is why we are able to use trigonometry to build stuff. Because if you can measure this, which we just did, we can use that knowledge to give us distances that we cannot measure, such as the length or the distance to a star. Is everybody with me? Okay? And this is how it works. The general statement we are going to make here is the length of the, I don't want to say sides, the length of the rays that form an angle do not affect the value nor the ratio between those rays. Is everybody cool? That is all you need to know to do trigonometry, which scares most people. Okay? We are going to talk. Now, how many of you have done some trig before? So for a lot of you, this is not new. Well, not a lot of you. For 4 of you, this is not new. You will know something that the other 26 kids in this room will not. You have to pretend like you don't know it. Okay? All right. Thank you. This particular ratio. Hello, grade 8s. Hello. Come on in. Meet the grade 10s. Come in. Don't be shy. If you're very lucky, you'll spend 4 months in here. If you're very lucky, you'll spend all 3 high school years of math in here. But only if you're a very special person. Not many people get that. In this room, we have a couple of people that are on their second tour of duty. Nice job, Karina. Anybody else? No, everyone else is new. Don't worry, you'll pick it up. Okay. Who's your guide right now? Nadia. Oh, hi, Nadia. I taught her. She was a superstar. You listen to what she has to say. She won't steer you wrong. Okay. Now go away. I'm teaching. Bye. Have good days. You too. I'll do my best.
Okay.
This particular ratio has a name. It is the tangent ratio. Okay? And it holds true for all right angle triangles. And this is what it means. The ratio of opposite to adjacent. Or the other ways we can write ratios. Opposite over adjacent. That's looks like a B. Adjacent. Okay? And it will always work. Here is the problem. Every angle from 0 to 90 degrees has a unique tan value. All right? What will change this, the 0.75, is the length of the sides. Everybody cool? All right. Now, this is my most frustrating moment in Math 10 because all of you have different calculators, okay? All of you need to do something for me right now. Everybody get out your calculator. Make sure you have it in front of you. One thing is the same for every calculator, and that is this. Okay, I'm going to slide over here to blank space because you guys don't need to write this down. Look on your calculator. That's the screen. Somewhere on your screen, make sure you see a letter D or the word DEG. Everybody must look right now. If you are using this calculator, is there anybody using the big fancy graphing calculator? Anyone? Anyone? No, that's regular. That's fine. No one is using this? Score! All right. Does everybody have a letter D or the word DEG? Okay. If you do not have those things, then you either have an R and rad or a G and grad.
This one was grad.
Does everybody have this now? If you do not have D or DEG, you are looking for this button on your calculator, DRG. And you need to push that button until it says D or DEG. If you do not have a D or DEG on your calculator, bring it to me now. Double check because I will be merciless if you walk up here. No. On the screen, Carmen, there needs to be a D or a DEG. Forget about the buttons. Look on the screen. Does it have a D or a DEG? It says, okay, you need to now find the DRG button and push it until it says DEG. DEG. Got it? See, this is a big problem. Once everybody gets it set up once, I never have to do this again, but it takes a while. Is she set? Bring me your calculator. It will be quicker. Come here. You have a D right there.
I know, but the DRG button.
Mode. Okay. See, because yours is in D and we can't find the button, it's not going to come out of D. So don't worry about it. Okay? All right, is everybody good? Okay, now, the next thing that is a problem. If your calculator is like mine, everybody, right now, push the button that says tan. If your calculator writes that on the screen, you have what I call a forward calculator, which means you get to punch in things the way you see them. When we were doing square root, it's the same thing. If you have to do square root 49 or 49 square root, all right? If your calculator writes the word tan, you're good. If your calculator doesn't, you have a backwards calculator, all right? So I want for everybody right now to take their calculators and make this happen. So if you have a forward calculator, you are going to push tan 35 equals. If you have a backwards calculator, you are going to push 35 tan. And here's the kicker. You will not need to push equals. That will mess you up later on. So be careful. And all of you should get a decimal. That decimal should be 0.700. Was everybody able to make that happen? Everyone could make that happen? Now, what that means is regardless of the size of the triangle, if the angle is 35 degrees, that comparison will always be 0.700. Does everybody understand? So if you can measure it on one triangle, you know it for every triangle that has that 35 degrees. Got it? Universally. Cool? Okay. So everybody can do that? Everybody made it work? All right, do the next two. Tan of 15 is 0.268. 3 decimals for tan. And tan of 45 is 1. Now let's explain why that works. I know you're giving tours. I'm having guests in all day. Tell them how lucky they will be to spend 4 months in here.
Yeah, what?
Good math teacher. I learned a lot. Funny guy. No, none of that. Gives gummy bears. We're going to try and get in his class. All right. In the blank space below those 3 numbers, you're going to draw 3 approximately right-angle triangles. They do not have to be perfect. Okay? This is where the 35 is. Put it there. And then write O and A, because 35 is, that side is opposite because it's across the triangle. That side is adjacent because it is beside the angle with which we are measuring. Does everybody understand that? Okay. Now, what you have just done, your calculator has gone ahead and told you that no matter the size of the triangle, this answer equals O divided by A, no matter what the number is. Everybody cool? Okay. So what does that mean for B? Here's the 15. I lie. I'm going to change it. I'm going to put the 15 up there. Where's the O? Where's O now? At the bottom, because it's across the way. And there is A. And this, no matter how big the triangle is, if you have a 15-degree angle, O divided by A will always be 0.268. Now, explain to me why the tan of 45 is 1. Talk to your neighbor if you need to. Tell me why everything's a decimal except that. What is it? Who would like to volunteer their group's discussion? How many people feel they have no idea why that's 1 instead of a crazy decimal? Some of you are in that boat? Okay. Karina, why is it 1? Right. If this is 45, how big is this angle? How big is this angle up here? If that's 45 and that's 90, how big does that angle have to be? 45, because triangles have to add up to 180, yes? And if those two are the same, that means this is an isosceles triangle, correct? Which means, what do we know about these two sides? They're the same. So that is O and that is A for this guy, aren't they? But for this 45, this is O and this is A. But since they're the same, O over A will equal 1. Everybody cool with the tangent ratio? All right. You can all use your calculators, yes? Okay. Now, when you turn your page over, you will see 3 new values. What is different about number 2 than number 1? Karina. In number 2, I do not know the angle. I know the decimal. Your calculator knows the angle. And here is how you find it. Tan gets you the ratio. All right? Tan with a little negative 1 gets you the angle. How do you get that tan with a little negative 1? That is second tan. On some calculators, it is shift tan. Otherwise, you follow the same rules. If you have a forward calculator here, you will push shift tan 0.75 equals. If you have a backwards calculator, you will reverse that. 0.75 shift tan equals. And tell me what the answer is.
Oh, I found it.
Some of you may need to close your brackets. It depends on your calculator. What's the answer? How much?
36.9.
Right. 36.87. Now, when we do angles, we don't actually measure angles in decimals. Angles are measured like time. They're measured in minutes and seconds, which is weird. So when we do angles, we usually round it off to the nearest angle. So this would be 37 degrees. Is everybody cool with that? Now, you should be able to tell me the value of angle A at the very beginning of this lesson. What is it? The green angle from the first page. How many degrees is it? 37. Why? Because tan 75 is 37. And that angle on the first sheet gave us the ratio of 0.37, of 0.75. Everybody with me? Okay. Now, don't do B yet. Do C. What is the value of C? So shift, tan, 2.5, 68 degrees. Is everybody cool? Now, what happened when you did B? Shift, tan, negative 1.23. You got from your calculator negative 51 degrees, didn't you? Does that make any kind of sense? It doesn't, does it? Right? How do you get a negative angle? Okay, this is all I'm going to show you because we're spending a whole bunch of time with this later on in the unit. But I wanted you to see it now. You guys are used to seeing angles from 0 to 180, yes? Except, how many degrees are there? There's another 180 down here, right? We count angles this way, from 0. So that is 0, this is 90, this is 180. What's this? 270, and this is also 360, yes? We count this way. So if we count this way, right, then this is positive. What did we just find? Negative. So which way would we count? This way is negative. And if I went negative 51 this way, what's that angle? All the way around is 360. And then I went negative 51 from there. So what is that? It's just logic, guys. I have 309. And watch. Tan 309. What will it be? Negative 1.23. Okay? We're going to spend a lot of time with this. You don't need to get it now. Don't worry. We are going to spend a lot of time with that. Okay, is everybody good? Okay, now, remember, for any specific angle, now stop for a second. You guys are smart kids. Which specific angles? There's how many angles in a triangle? 3. Which one have we not talked about? Here's a triangle. We've talked about this guy. We've talked about this guy. Have we talked about the 90? Why? Why can't we talk about the 90? Partially because it's 90 degrees. But what happens on your calculator if you do tan 90? Just try it. It's an error. Why? What is tan? How do we find the tan decimal? What do we need to use? There's my angle. I need an opposite and an adjacent, don't I? Opposite's across the way. Adjacent is right beside, yes? Okay. So why won't that work with the 90? What's opposite from the 90? The hypotenuse. What's adjacent? Both. Okay? So tan of 90 doesn't exist. It's undefined. It's like dividing by 0. You can't get it. Now, just for fun again, what do you think will happen if you try to do the tan of 89.9 degrees, which is almost 90? Don't do it. Think about it for a sec. What will it be? Colossally large or colossally small? Look at your notes. Look at what happened in your notes. In your notes, 37 got me 0.75. 68 got me 2.5. What is happening as my angles get bigger? My tangent is getting what? 0.75, 2.5. So what is going to happen if I ask you for tan 89.9? Right? It gets big. Tan of 89.9, a big number, right? Tan of 89.99. It's going to get bigger and bigger and bigger. What will it never get to? Tan 89.999999999. What will it be? I'm really close to 90, aren't I? Impossibly close to 90, yes? So what's this number going to be when I hit equals? Impossibly large. 5.72957. That decimal will move 10 places. Understand? It will never get anywhere because it can't exist. It is infinite. Do you understand me? Okay, good. So now, let's see if we can put this into practice. Of course, we can't because my screen is frozen. Because I have 3 different applications open. And, that can't possibly work with this $4,000 machine. Thank you, Bill Gates. So we are right here. All right, so now, for any specific, which angle? Is the right angle allowed? No. So do a bit of highlighting here. For any specific acute angle in a right angle triangle, the tangent ratio compares the opposite side to the adjacent side. And please remember, in trigonometry, as in all geometry, opposite means what? Across. Okay? Across from where? From the angle which you are viewing. And here is what I mean. In this next question, what is the tangent ratio for angle A? Where does that mean we are starting? I want the tangent for angle A. So where should I draw my happy face? At A, B, or C? You got a 33% chance, even if you have no idea what I'm saying. Tavleen. Yes, because I would be looking at it from angle A. Understand? So from angle A, because that's where I am, the opposite and the adjacent, it's opposite over adjacent, so it is 12 over 5. Understand? Now, I'm going for a walk. Actually, I'm going for a slide. Woo! And now I'm down at B. What is the tangent of B? Is it still opposite over adjacent? Yes, because it's always opposite over adjacent. But I'm in a new spot, so opposite and adjacent changes. What is the tan of B? 5 over 12. Is everybody good? Okay. Now I want you to find those angles. There's the ratio. Since I want an angle, is that tan or shift tan? Shift tan. Angles means shift tan. And as you can see, my computer is dropping my ink line, so I'm going to try turning it off. Now it's frozen. While you are waiting for my $4,000 paperweight to work, I would like for you to tell me those two angles. Remember, you do not need a decimal. You can use your brackets and that fraction to find it. See if you can figure it out while I wait for my computer to do what it is supposed to do. Not anything special, just what it's supposed to do. Because heaven forbid my technology work. All right, so. Oh, I left some of my hair up in A. That's because I'm getting old. I'm going bald. When I slid down, I slid so fast, I lost some more hair. So A, how will I find A? I know I need shift tan, yes? So I know it is shift tan of 5 over 12. How do I punch that into my calculator? In one go? If you have a forward calculator, shift, tan, bracket, 5 divided by 12. Oh, wait, A was 12 over 5. So I'm going to do B first. Right? And what does that get me for an angle for B? 67. And A equals 12 over 5. So I would go shift, tan, bracket, 12 divided by 5, close brackets, equals. And get what? 23. Can everybody do this?
Yes.
Okay. Angle A is 12 over 5. I wrote them backwards. I did A over here, B over there. Okay, well, you guys told me B was 67. I didn't punch it in. All right. Is everybody good? Okay. Now, I have already done this here, right? This is right here. No, I lie. Right here and here. Can everybody do this? Okay. Now, in this blank space here, because we've already written this down, I want to give you guys a little bit more notation. In math class, because the Greeks invented most of the stuff we do with geometry. We use a lot of Greek letters. An unknown angle equals theta, which is a Greek letter, and it looks like this. It's a circle with a line through it. Yes, in 5 minutes. We'll phone down to Crossroads. That's what an unknown angle means. So any angle for which you seek, some textbooks and some teachers will talk about theta. It just means an unknown angle. Okay? So just chill. People get, what's theta? It's just an unknown angle. So let's check. So what does that mean? Some textbooks and some of the work, if you try to do extra work on the internet for practice, you might see this. Tan theta equals opposite over adjacent. Theta just means any angle. Okay? So I'm going to show you guys something that seems stupid, easy, and like, why would I even do that, Mr. Myers? That's so dumb. I'm smarter than that. I don't care. Do this until you are so good at trig that you don't need to do it anymore. I stopped doing what I'm about to show you 3 years ago. That's how long it took me to feel I was good enough at trig that I could stop doing what I'm about to show you. Okay? Every trig question, every physics question, every formula, all do this. What do you know? Do you know theta here? No, because it says right there we are seeking that angle and it is unknown. So theta equals x. Yes? What do I know in this triangle? If this is x, that's the angle I'm starting at, yes? So I draw myself right there. You don't need to draw yourself. But that's the angle you care about. What do you know in this triangle? What is that? Opposite. So opposite equals 23, yes? What is that? Adjacent equals 15. Since I have an unknown angle, is it shift tan or tan? Shift tan. So I need shift tan of theta equals opposite over adjacent, yes? What is O? 23. What is A? 15. Punch that in and tell me what theta is. 57 degrees. Is everybody good? Okay, now, no one is going to say the answer to B out loud. They're just going to attempt it after they set it up. What is theta in B? What's the angle with which we are dealing?
Lower.
Give me a value. It's right here. It's the angle we are working. So it is 15. Okay? Since we are working with angle F, you're right. We could have done that. Theta equals F equals 15. That means this is the angle where we are starting. What do I have? I have the opposite. What is it? X. I have an adjacent. What is it? 37. Since I know the angle and I need a side, is it tan or shift tan? Tan. So I write it out. Tan of theta equals O over A. So it's tan 15 equals O, which is X over 37. Does this look familiar? It should, because it's just algebra, isn't it? How will you solve this? Yes, of course you just switch it, but why, Tavleen? Everybody said you just switch it. I agree with you, because that's what you do. Why does that work? Yes. How do I get rid of divided by 37? So if I multiply this side by 37, what do I have to do to this side? Multiply. So this becomes 37 tan 15 equals x. Right? How do I punch that into my calculator? 37 times whatever you do for your calculator. We've just practiced it 20 times. It's either tan 15 or 15 tan, right? Will get me what? And don't say it out loud. 37 times tan 15. Close brackets if you need to. Is everybody good? Now here is where you're going to have a problem. How many people have a backwards calculator? As soon as you hit 15 tan, your screen fills up. Are you done? No, because what have you not hit? Equals. You must hit equals for your calculator to give you an answer. Okay? I have lost count. If I had a nickel for every kid that told me this answer was the tan of 15, which is like 0.153 or something, I would be a rich man because they forgot to hit equals. Everybody cool? All right. Now do the next one. What is my theta? 70. What is my O? 14. What is my A? X. So tan 70 equals O 14 over X. Now we've already did this last unit when we were moving around formulas, right? Technically, I multiply both sides by X, and I get X tan 70 equals 14. Then I divide both sides by tan 70 to isolate X as 14 over tan 70. Yes? Technically. What is the reality? You switch it. When the variable's on the bottom, they switch places. 14 divided by tan. When the variable's on the top, it switches. 37 times tan. That's what you do. This is why it works. Make sure you know both. How will I punch that into my calculator? What do I do? He waited patiently. Over here, you did 37 times tan 15. So what do you do here? Max?
So my calculator is different.
Doesn't. No, it's not. It's just backwards.
Yeah.
So what do you do?
Well, what I did was, I did 14 divided by 70 tan.
70 tan.
Yeah.
Right? So for most of us, it's going to be tan 70 equals. For the backwards calculator people, you have to reverse the 70 and the tan. Everybody got it? Now, listen to me and listen to me carefully. How many sides are there on a triangle? 3. What is the one side that tangent will not help you with? The hypotenuse. Tangent will only help you find the legs, which means what must you do to get a hypotenuse? Pythagoras. Write that down somewhere. Tan never gets you the hypotenuse. If you need the hypotenuse, you must tan, then Pythagoras. Clear? All right. Now, your guys' next page should be a triangle. Or 4.
Yeah.
Let's do this page, then I'm going to shut up. You're going to do the next work, which is the next page in your book. So, this triangle here, what do I know? Do I have a theta? Do I have an angle that I can put information in for? What is it, Shotzi? 30. What else do I know? If I'm using 30, that is my viewpoint, yes? So that is where I find my O's and my A's. What is opposite to 30? O equals X and adjacent equals 24. Can we use that information to find X? What will I write? Tan of what? Tan of what? Tan theta equals O over A. So tan of what? Tan 30 equals X over 24. Numbers on the bottom, so is it multiply or divide? Multiply. So 24 tan 30 equals X. Find out what X is, and then do not push clear on your calculator. 24 tan 30. So everyone should be looking at 13.85, yes? Everyone agree? I have 13.85. My calculator is stuck halfway off the screen. Thank goodness for technology again. Everybody cool? Why have I written this here but told you to leave that on there? Because we're not done, are we? Exactly. Tavlee knows we need this. She knows we need this. She knows this is an approximation. So she is going to leave that there to get the most exact answer she can. What will find us y? Y is the hypotenuse, yes? So y is the square root of O squared plus A squared, yes? Right? What is O squared? Well, we just wrote it as 13.85 squared. But it's sitting right there on our calculator, yes? That's why I want you to leave it there. Plus A squared is 24 squared. So, you can punch this in one go, but it's a little difficult. Most of you will probably want to do what I'm about to do. There's your answer, yes? So if I hit squared, answer squared, or your calculator will do it, it's going to be around 171 plus 24 squared, and I get that. Then what do I do? Square root 768. Or square root answer, if you're good with your answer button. 27.71. Can everybody do that? That's trig. That is the only skill you need to do trigonometry. If you can do this, you can do everything we are going to do for the next 3 months. Not 3 months. Everything we are going to do for the next 3 weeks. And if you go out on the street and say, I can do trigonometry, people will think, you're a wizard, Harry. Because people think it's difficult. You know those dudes and women that are standing on the side of the road in high-vis vests, looking through a telescope at another dude far away? Have you seen those dudes? Those people are being paid like $100,000 a year to do grade 10 trig. Because all they're doing is looking through the telescope, finding angles, and doing this. It's called surveying. And there's a buttload of money to be made doing it, if you can do grade 10 trig. So let's do these last three, and then I'm shutting up. In this one, I'm going to work this one in red. Do I have a theta? No, what is it? x. So now that means this is my starting point. So what's O? 35. What's A? 50. What uses O and A? Tan of x equals 35 over 50. Since I need an angle, is it shift tan or regular tan? Shift tan. 35 over 50. Punch that into your calculator and tell me what x is. Shift tan. 35 divided by 50. $35, because degrees we like to the nearest one, yes? Tavleen. I have an answer.
All right, okay, I just have a question. Okay, you did shift 10 divided by...
No, shift tan,
10 times.
bracket, 35 divided by 50, close bracket, equals.
Okay, but how would you, can you just explain how you switched around that to get that formula from the 10 times?
Okay, the regular formula is tan theta equals O over A, yes? Well, I didn't have a theta, so I had to leave that unknown. And then the O is 35 and the A is 50. Okay, so all you do is use your calculator to get this from this decimal. Yeah, shift tan. That's to tell me that I'm doing shift tan because I need an angle. Okay, this is tan of x equals that, but I don't know x. Shift tan will tell me x. Okay? All right. Everybody cool with that one? Okay, let's do this one. What do I know in the middle triangle? Do I have a theta? What is it? 60, which means that's where I'm starting from. What do I know? O is x. A is 7. And that will find me my missing side to do hypotenuse, yes? So let's do this first. Tan of what? 60 equals what? X over 7. What do I do there? 7 tan 60, right? What does that get me? $12.12. Am I going to clear that? Why? Because I'm not done. Y equals the square root of what? 7 squared plus 12.12 squared. Punch that into your calculator. Square root. I'm using my brackets. 49 plus... I'm using my last answer, because my last answer was 12.12. Close the brackets. Oops, I forgot to do squared. If you did clear it, you've written it down, 12.12, so you will still get an approximate answer, which is good enough for me. So how long is y? 14. Is everybody good? Okay, and the last question, which I will work in green. Do I have a theta? What is it? 80. O is what? 10. A is what? X. Tan 80 equals 10 over x. X is on the bottom, so what math is it? X equals 10 divided by tan 80. What's x? Can everyone do trig with tan? Okay, here is all you need to remember. You need a triangle. Does it matter what the triangle looks like? No, this is not art class. Doesn't matter. Yep. Doesn't matter what your triangle looks like. You can't do trig without a triangle. So if you're doing a trig question, you don't know what to do, what should you do? You should draw a triangle and set it up. If it tells you that one of the angles is 10, where can you write 10? On either of these two, correct? Because you're only using this to help you. I'm going to make that 10. And then if it tells you the opposite is 15, well, there's your opposite. Cool? All right. So you guys you've done enough practice. Your next page in your notes should be page 76, 10, 11, 14, 19, 20. And if you look on your outline at the beginning of the section, that's what I asked you to do right now. Right there, that's what you're doing, except I've cut it down. Because you guys don't need to do all that. That was out of the old textbook. You're doing just this page. And it is all right there, including answers. The answers, I think, are right at the bottom. Sometimes those answers are upside down, sometimes they're on the next page. It just depends on how the scanning worked. Okay? If you can cram your work onto this page, go ahead. If you want to use your own paper, go ahead. Okay? And obviously we didn't get to the test, so we'll get to it tomorrow. Unless you want to write it at lunch. Yeah. Well then, no. I'll see you tomorrow. You'll do it tomorrow when we go over the test. Everybody cool? You can work on this page if you want. There's lots of white space. Go ahead and use it.